So this is the Sprint 1 video for CrowdCheer, the summary video. And I had half a sprint to work on stuff this time because I was out of town. But for that time, I worked on building out some of the architecture work that we had started at the end of last quarter. And last quarter, we started working on the part of the architecture, which is this tracking protocol. We started building this out, and this involves collecting location data and storing that data in a way that's useful for us for both user classes, the runners, and then our spectators, the cheerers. But at the end of last quarter, there were some bugs, and some of the data wasn't storing properly, and we had some location authorization issues. So I spent the beginning of the sprint debugging some of that and ironing out the tracking protocol. And then the second half of the sprint, working on the monitoring protocol and implementing that. So the monitoring protocol really thinks about, as a cheerer, what runners are around you and how to track them and what information is relevant in that scenario where you have a bunch of runners around you. And once we have the ability to track the runners around you, eventually we want to use that data and show the spectator, well, here are the runners that are around you, and give them the opportunity to kind of pick which ones they care about and then eventually cheer for them. So this was setting up, this protocol kind of sets up all of that. For the tracking protocol, in terms of debugging, it was mostly just fixing some of the stuff with the location manager and authorizing it because we were getting spammed with notifications and it wasn't actually storing the location data because the authorization wasn't happening in the way that it needed to. So that's happening now. And I guess that's just like a quick overview of the tracking protocol. We have a runner tracker class. The protocol is defined up here. So we have a tracking protocol, and then we have two classes that implement that protocol. So there's the runner tracker class, and this is how to track a runner essentially throughout the race. So the main functions here are saving the user location, which has to do with this is actually saving the current user location because there are times where instead of looking at all the location updates for the runner through the entire race, we just want the most recently updated location. So I added this function in because this actually ends up being really useful for the monitoring protocol because we only care about the last place the runner was in for that. Saving the user path just has to do with saving, let's see. Oh yeah, this is just saving all location points that the runner has gone on so that afterwards we could plot out their path for their run. And then for the cheerer tracker, we've got the same kind of stuff. And then track user location was in both of them as well. And that just has to do with updating the location points using the location manager. So that's the tracking protocol. And it's a lot easier to debug and work with because how much we broke it down into the different classes and functions. So I think that is really helpful in terms of setting up an architecture for your app. And then for the monitoring protocol, this is the one I implemented this sprint. So this is the monitoring protocol. It has various functions in it. Monitor cheer zone, this one here, is the main function that ends up being implemented in the whatever uses that protocol. So for the monitor runners class, I wrote out this function here for monitor cheer zone. Eventually we want to be able to have just monitor runners in general, which is this first class. And then specifically monitor my runner, meaning like if you're going to a race with somebody, you want to prioritize the person that you're going to cheer for. So that's going to handle that eventually, but we're just doing minimal stuff here to get the architecture set up. So this is what I focused on. So this function runs a much more detailed parse query and more scoped than we were using before, and just the way that we set up the data makes it a lot easier. So we're looking for specifically runners that have updated within the past X number of seconds. For testing purposes, I'm doing in the last 10 minutes, but this is really easy to change. And then also sorting it sorting it by who was updated most recently, and then there's also a way that you could do parse queries where you could say, based on a location point, only give me location points that are within X kilometers or whatever distance of another point. So we can use this to say, only give me runners that are nearby the cheerer's location, which is pretty cool. We didn't use that before, and this makes things a lot smoother in terms of how quickly the app runs and how small the query is. So that's pretty nice. Yeah, and then it just runs through the query and it returns. I started working on using a dictionary instead of an array because we want to be able to return back a dictionary that has runner objects in them and then also their most recent location. And then that's passed back, or the view controller, the race view controller, handles all of this data. So in terms of displaying it, the view controller right now runs the user tracker, and the user tracker just deals with storing location points back into parse. And then update nearby runners, which is set off by a timer here. Update nearby runners goes through that dictionary or array as I have it set up right now, and displays the most recent locations for anybody near you on your view controller. So that's like a very basic layout right now, but obviously in future iterations we're going to kind of beef that up and set it up so that it could do more things with that data. But this is just so that we can see the data flow. And that's what I worked on this sprint.